In this video, we will discuss about an exam eigenvalues of a 3 by 3 matrix. Suppose we have this 3 by 3 matrix and we have to find out its eigenvalues. As we know that for finding the eigenvalues, we need the characteristic equation which is given by determinant of a minus lambda I is equal to 0. If we have other method or other formula to write down the characteristic equation which is for a 3 by 3 matrix which is given by lambda cube minus trace of a into lambda square plus sum of the cofactors of the diagonal entries of the matrix times lambda minus determinant of a is equal to 0. So if we can find the values of trace of a and the determinant of a and the diagonal entries cofactors, then we will get the eigen characteristic equation. So trace of a, you know that is can be calculated by the sum of the diagonal entries. Now we will find out the cofactor corresponding to the entry a11. So just remove first row and first column, then find the determinant of the remaining 2 by 2 matrix, which will be minus 4 plus 6, it will be 2. Now find the cofactor corresponding to entry A22, which is represented by C22, which can be obtained by just cancelling out the corresponding rows and columns and find out the determinant. Similarly, find the cofactor corresponding to the entry A33. So just find out the determinant of this. So it will be 8. Now the sum of these cofactors will be 8 plus 1 plus 2, it is 11. Now the third one is the determinant of a. So the matrix is given as this. Now we will find the determinant by the expansion of first row. So just we can calculate the determinant in this way. It will comes out to be 6. So determinant of a is 6. Now the values of trace of a, the sum of diagonal entries and the determinant. Put all these values in equation 1. So we will get our characteristic equation as lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. So we know that how so this is our characteristic equation, and the roots of this equation will be our desired eigenvalues, and we know that how to solve such a cubic equation. So we can observe that lambda is equal to 1 is a factor, is a root of this equation. That means lambda minus 1 is a factor. So the remaining portion will be lambda square minus 5 lambda plus 6 will be 0. So just factorize it, you will get the roots of this equation as lambda is equal to 1, 2 and 3. So these are the eigenvalues of the matrix A. Now we will find out the eigenvector of these eigenvalues. So for finding out the corresponding eigenvectors, we know that by the definition of eigenvalue, ax is equal to lambda x. So we can write it down this equation as a minus lambda I x is equal to 0. So suppose x is the corresponding eigenvector for the eigenvalue lambda. So a minus lambda I will be given by this matrix. So this is the corresponding eigenvector. So we will put the values of lambda as 1, 2 and 3, and then we will find out the corresponding eigenvector. So let us start with the case when lambda is equal to 1. So that system a minus lambda I will become as 2 4 minus 2 1 3 minus 1 2 6 minus 2. So now just multiply this matrix with this corresponding vector x. We will get a homogeneous system of linear equation as 2x1 plus 4x2 minus 2x3 is equal to 0. x1 plus 3x2 minus x3 is equal to 0, and 2x1 plus 6x2 minus 2x3 is equal to 0. Now let us solve this system of linear equation. So we can rewrite that system of linear equation by this. So we just divide the third equation by 2, so we get this equation. So if you see here in this system, the last two equations are identical. That means this equation is redundant. So our system will be reduced to this. Now just use eliminate x1 from the second equation using using first equation. We will get x2 as 0. Now just use the value of x2 in equation 1. We will have x1 is equal to x3. So we will have the eigenvector whose first and third component will be same and the second component will be 0. So in particular, if we can take x1 is equal to t for any scalar t, so it will be t0 t. We can take t common, so it is a 1 0 1. So this vector 1 0 1 will work as the basis for this eigenspace. So in particular, if you take t is equal to 1, so 1 0 1 will be our corresponding eigenvector corresponding to the eigenvalue lambda is equal to 1. Now let's come to lambda is equal to 2. Again we have this equation. Now put lambda is equal to 2 in this equation. We will get the matrix such as this. Again we will multiply this matrix to this corresponding eigenvector, and we will get again a homogeneous system of linear equation. So it will be x1 plus 4x2 minus 2x3 is equal to 0. x1 plus 2x2 minus x3 is equal to 0, and 2x1 plus 6x2 minus 3x3 is equal to 0. Now just again solve this system. Remove x1 from second and third equation. Using this equation we will get minus 2x2 minus plus x3 is equal to 0. In the third equation again we will get the same thing, minus 2x2 plus x3 is equal to 0. So again if you see in this system, these last two equations are same. That means this equation is redundant. So this system will becomes this. Now in this system, if you see these equations, the variables x1 and x2 are the leading variables in this system. So x3 is not present in the leading variable, so it means this x3 is our free variable. So we can take x3 as any scalar. For example, we take x3 as t here. So just use this value in the second equation. We will get the value of x2 as t by 2. Now using these two values in equation 1, we will find the value of x1 as zero. So we have eigenvector 0, t by 2 and t. So we can take t again common. So 0, 1 by 2 and 1 will work as the basis for this eigenspace. So if we take in particular t is equal to 1, so 0, 1 by 2 and 1 will work as a corresponding eigenvector to the eigenvalue lambda is equal to 2. Again, consider for lambda is equal to 3. Again, we will take this equation. Now put lambda is equal to 3 in this matrix equation. We will get this. Now just multiply equation and get the corresponding homogeneous system. We will get so now again because in the first variable we have 0, so we will replace we will put first equation as the first variable, or just rewrite this system of linear equation in this way. Just divided by 2 first equation, so we will get this one. And again that means when you solve it this system, so you will get these two equations again. X1 and x2 are the leading variables here, and x3 will work as the free variable, so you can take x3 as t. So when you put this value in the second equation, you will get the value of x2 as t by 2. Now using these two values in equation 1, you will get the value of x1 as t by 2. So the corresponding eigenvector will be t by 2, t by 2 and t. You can take t outside. So again 1 by 2, 1 by 2 and 1, and this will be our corresponding eigenvector. So I hope that with the help of this example you learn how to find the eigenvalues and the eigenvectors. Thank you.